guys, today I said in the last video I'm gonna do question 4. Okay, so question 4 is organic, and they've asked for a lot of organic stuff. Okay, without any further ado, let's just skip on to the question. So, what type of isomerism do RST show? The first thing you must notice is that I'll highlight this in red. CO2 is here, CO2 is here, and CO2 is here, right? Have you noticed? So isn't it obvious what type of isomerism? That is positional isomerism, isn't it? Right? Right? Isn't it positional isomerism? But they asked you to show the type, so we cannot say positional. This is an informal word, so you have to say structural. Okay? So what oxygen-containing functional groups are present in RSNT? Give their full name. Full names means you need to state whether they're primary, secondary, tertiary, and so on. So first we need to draw R, which is HO. So I'm gonna draw R, and this side, that's all. This is just here. So just drawing out R would be not be quite hard. Except I hope it shouldn't be hard. OH, and there is oops. I don't know what's wrong with this pen. Okay, this one. So you've got C, and there's a OH. There is H2 attached to it, CH2, and then there's a CH2 attached, and then there's a COOH. Right? So you can see immediately the two functional groups. The special thing, the oxygen, they wanted oxygen containing functional groups, right? So oxygen containing functional groups are one with the OH and one with the COOH, which means that they contain, this is a primary alcohol, right? Is it primary? Is it primary? It's supposed to be primary, right? It's primary alcohol. So it's primary. Primary alcohol, and the other one is definitely carboxylic acid, which is the COOH drawn there. Okay, so ACE, S, what is S? HO, CH2, so you've got CH2 is the same. Okay, there's a CO2, which means this and this way. 1, 2, 3, 4. No, it can't be that way. COO, CO2, CH3, right? CO2, CH3. So there's only one solution you can make out. We have to put a O here, and then we have to put the O here, and then there's a CH3 here. So you can see this is directly, you can see this is alcohol, and this is ester, right? It's an ester. So you can have alcohol and ester. And ester, or whatever you like to call it. Okay, T is HCO2, H, and then C, O2. So again, when they have CO2 in the middle, we've got no choice but to make it an ester, CH2, CH2, and there's a OH. So OH is definitely alcohol. Another thing I think we didn't mention the term here. So it's a primary, okay? I forgot about the term. Ester is not primary, secondary, tertiary ester, so we can just let it be. So this is an ester, this is an alcohol, of course, a primary alcohol of that. So it's primary alcohol. So you see, all three of them contain a primary alcohol group, and two of them contain an ester. One is a carboxylic acid. So which functional groups will react with the sodium carbonate? Sodium carbonate, carboxylic acid, right? So that is carboxylic acid only. Okay, and with the sodium metal, they've asked next is sodium metal. Sodium metal is just a primary alcohol. Another thing, mention the full thing, do not just put in alcohol. You may or may not get a mark if you just put down alcohol, but it's always safer to put it in primary. Alcohol, and you must know it reacts with carboxylics.
Okay, so carboxylics,
Carboxylic acid, okay. E part 1. When 0.02 mole of Q is reacted with an excess of solid sodium carbonate, and so Q is the one that, where's Q? Where's Q? Oh yeah. Okay, so oh yeah. So Q, okay, is reacted with an excess of solid sodium carbonate. 24 centimeter cube of carbon dioxide measured at room temperature and pressure is produced at RTP. Calculate the amount in moles of carbon dioxide produced. So you need data from the data booklet if you don't remember. That is. So you can see that in the data booklet it shows that at RDP it is 24, right? So number of CO2 is equal to 24 over 24,000, right? You see they put in 24 dm cube. We have it in cm cube, so it's 1 times 10 to the power of -3 mole, right? Hence calculate the amount of moles produced by 1 mole of Q. So they have 0.002 mole gives you 0.001 mole, right? So if they produce, so they've got 0.002 gives you 0.001. So if they got 1 mole, how much is this one? Just multiply. Equal to 0.0001, or not 3 zeros, just 2 zeros. Just 2 zeros after the decimal point. 2. So you can just say it is 0.5 mole of CO2. So another method is to say 0.002, 0.001 half, so 1 mole half issue. And 0.002 mole of Q is reacted with an excess of metallic sodium. 48 centimeter cube of hydrogen measured at RTP is produced. Calculate the amount in moles of hydrogen produced. So moles of H2 hydrogen produced is, you must know, 48 divided by 24,000, which means it's 3 times 10 to the power of negative 3. Okay, hence calculate the amount of moles. So you've got the same thing here. We divide 0.001 divided by 0.002. Similarly, we're going to divide 0.003 over 0.002, which gives you 1.5 mole, right? Use your answers to B and C to deduce which structure corresponds to the structure of Q and write balanced equations for the reactions that occurred. Okay, so identity of Q is definitely the one that reacts with both, which is, so it reacts with both, right? So it reacts with it reacts with sodium as well as sodium carbonate. So it means that when it reacts with sodium carbonate, it means that it's a carboxylic acid, and it has to be a primary alcohol. So it's definitely R, because only a carboxylic acid can do the job. You must remember the first one is a substitute. The first one is when one hydrogen is substituted for by sodium and water and carbon dioxide. You must remember the carbon dioxide. So I'm just gonna write down the equation. And water and carbon dioxide. Okay, with sodium metal, so it means sodium goes in and hydrogen comes out, right? So you must know the ratio. So for every 1 mole of this one, so for every 1 mole of the organic reactants, you must have half mole of carbon dioxide, right? So for 2 moles, you must have 1 mole. So there has to be a CO2 there. So the CO2 is definitely removed from here, and you've got Na2O remaining, and there are 2 Na's going in, so there are 2 H's coming out. So there's 2 H and 1 O, and they go with the H2O. Okay, so the equation for reaction is sodium metal. So sodium, or you see up there, you needed 2 atoms of sodium. Here you still need 2 atoms of sodium, because you're still gonna replace the 2 atoms, except for that you are not having a CO3 along with you. So of course the reactant remains the same, and 2 H's are replaced, and with the 2 H they go together to form a hydrogen gas. So okay, so this is question 5, which will be covered in the next video, guys.